Good afternoon, students. Today we are discussing optical fiber. In last class, we discussed about photoelectric effect and photoelectric cell, photoelectric applications we discussed. In today's class, we are going to discuss about another modern technology, that is optical fiber. Optical fiber is a technology that can be used to data transmission. Okay, so optical fiber is mainly used to data transmission depending upon the light waves, and these waves are electromagnetic waves. These waves carries the data to longer distances with fewer damages. Okay, now in today's class, how optical fiber can works, what are the applications of optical fiber, and on which properties of light this optical fiber can work, we discuss. Okay, so our chapter name is optical fiber. So before going to discuss about optical fiber, first we have to know about few basic properties of light. What are they? They are refraction of light, critical angle, total internal reflection. If you know about these three properties, then it is easy to understand how an optical fiber can work. So let's start with refraction of light. Look at here. We are going to discuss about refraction of light. What is refraction of light? Refraction of light means the light has a bending property when it travels from one medium to another medium. At the point of incidence, it bends, and this property is known as a refraction of light. If you observe the figure shown in this PPT, we are taking one incident ray. This is a light ray, and we named it as incident ray because it incident on the boundary at the point of incidence, and it enters into the another medium. We are taking two mediums here, that is, one medium is air medium, which is treated as a rarer medium, and another medium is water, which is treated as a denser medium. And our light ray incident at a point of incidence, and it bends into the another medium, it enters into the another medium, that means denser medium, by bending. Look at here, incident ray, and it incident at a point of incident, and after striking a point of incidence, it bends towards the normal. Normal is a imaginary line, it is indicated with n. The angle between incident ray and normal is called angle of incidence, which is denoted by small I, and the angle between the refracted ray and the normal is called refraction angle, that is denoted with small r. Look at here, when light ray enter into the another medium, it bends, it does not going straight forward. That line is not entered into the another medium as a straight line, it bends. This bending property of light is called refraction of light. Already you know about this property in your lower classes. Okay, if you understand this refraction of light, then it becomes easier to understand the working of optical fiber. Once again, I am showing the definition of refraction of light. The phenomenon of bending of light, or we can say that the property of bending of light at the boundary. This boundary means it boundary separates the two mediums. It can sometimes called medium 1. Above the boundary line is medium 1 and below the boundary is medium 2, and above the boundary line sometimes called it as a rarer medium, and below the boundary line is a denser medium. The boundary line which separates the two mediums. So what happened at the boundary? At the boundary, the lights bends and entered into the another medium. The phenomenon of bending of light at the boundary between two different media is called a refraction of light. This is the basic property of light, which is we are observing in our daily life. Look at here, I is called angle of incidence and R is called angle of refraction. This is the first property of the light we are discussing to better understand the working of optical fiber. Look at here once again. So now I am going to show some more examples to understand the refraction of light. Look at here, a pencil was dipped into the glass of water, and it looks the pencil bended inside the water. Actually, it appears like the pencil is bended in water, but which is actually not bended. The light surrounding that pencil is also entered into the water, and that light is bended. The light around the pencil was bended, not pencil is bended, but the image captured by our eyes depending upon the bended light. That's why that pencil also looks like the bended one, but pencil was not bended. Pencil is straight, but when we dip into the water, it enters into the another medium, and the light around the light rays around the pencil are bended. They are showing the refraction property, those light rays which are entered into that water medium, that means denser medium, and that is reflected, and our eyes captured that images as a bended pencil. So it is a complete illustration of the bending light. Okay, now I am showing some another ppt for better understanding of refraction of light. Look at here, a person is targeting a fish with the help of a spear. Okay, look at here, the fish is it in different place, but due to the bending of light it looks somewhere, and it creates some another image in some another place, because the light bends, and the bending light bring another image to the person who is hunting fish. Okay, this is because of bending of light, that means refraction of light. He sees the image, real image, instead of real image he is seeing some another image at another place. Okay, right. So in this way we are discussing refraction of light. Once again, I want to explain the refraction of light. Refraction of light means it's a property of light. What property? The bending property of a light is called refraction of light. When it enters into the one medium to another medium at a point of incidence. Okay, this property is called refraction of light, the phenomenon or the process in which the light ray bends when it enters from one medium to another medium. You have to remember this. Okay, and next topic is critical angle. What is critical angle? Look at here. Light ray travels from not only rarer medium to denser medium, it also travels from denser medium to rarer medium also. What happened when a light ray travels from denser medium to rarer medium, and if its makes refracted angle is 90 degrees, then what happened? Look at here. The critical angle is defined as the angle of incidence in denser medium for which the angle of refraction is becomes 90 degrees. Look at here. A light ray, incident ray, that means light ray, we are calling light ray which are going to strike at a point of incidence, that is incident ray. This incident ray at normal makes an refraction angle that is exactly 90 degrees. If it makes exactly 90 degrees angle, then that refracted ray is travel along the boundary. Look at here. It is not refracted into the another medium. Instead of refraction, it travels along the boundary. When this phenomenon occurred, when the angle of incidence for which angle of refraction becomes 90 degrees. Okay, whenever angle of incidence is happen alternately in another medium, refraction angle also created. If that refraction angle becomes exactly 90 degrees, then that light ray is not bended. Instead of bending, it travels along the boundary line which separates the two mediums, and it travels along that boundary. This property and that angle is called critical angle, where the refracted ray travel along the boundary line is called critical angle. Look at here. In this PPT, I drawn a normal line and a boundary. Above the boundary, I am taking rarer medium, air as a rarer medium, and below the boundary, I am taking water as a denser medium. And now, a light ray traveling from sorry a light ray which is in a denser medium and strikes at a point of incidence, and it makes angle of refraction as 90 degrees, and it travels along the boundary line. Please observe the blue color line as a incident ray and the refracted rays. Here R is equal to 90 degrees indicates the refraction angle is 90, and the dotted line is indicates normal. Compare this with the refraction of light. In refraction of light, look at here. For angle of incidence, the angle of refraction is not 90 degrees in refraction of light. If it makes 90 degrees, then that light ray travels along the boundary, and that r is equal to 90 degrees is called a critical angle. Simply we can define it as that when a light ray travels from denser medium to rarer medium, for which angle of incidence, for which the angle of refraction becomes 90 degrees, then that angle is called critical angle. This is also one of the important property of light, for it is useful to understand the working of optical fiber. These are the basic principle we have to know about light. And the next major and most important property is total internal reflection. What is total internal reflection? Total internal reflection means when a light ray travels from denser medium to rarer medium, the angle of incidence is greater than critical angle, and that ray is reflected back into the same medium. This phenomenon is called total internal reflection. In refraction of light, the light ray bends in critical angle, the refracted ray travel along the boundary. Why? In that case, the angle of refraction becomes 90 degrees. That's why it is travel along the boundary. If it is less than the 90 degrees, it is bent. But here, in this case, the angle of refraction is greater than critical angle. Greater than critical angle means greater than 90 degrees. In that case, light ray completely reflected back into the same medium. That means denser medium. Okay, this property of light is called total internal reflection. Okay, you don't confuse between the diffraction of light, critical angle, total internal reflection. You have to clarity what is diffraction of light, what is critical angle, what is total internal reflection. Okay, so I am showing one ppt. In that you clearly understand, in one ppt I am showing three topics. Look at here. Here I am taking two mediums, medium 1 and medium 2. First one, the reflected ray. Look at here, it is reflected ray, and the second one is reflected as theta c, means critical angle is denoted with c. Theta c means critical angle. If it is greater than, the reflected ray makes a refraction angle greater than critical angle, it is completely reflected back into the same medium, and that phenomenon is called total internal reflection. Look at here. Here in first figure I am explaining about refraction of light. Incident ray incident, and it is refracted into another medium. In critical angle figure, second figure, the angle of incidence for which angle of refraction is 90 degrees. That's why the light ray travels along the boundary. It is shown with a black color line. If you observe the total internal reflection, look at here. What happened in this case? angle of incidence for which angle of refraction is greater than critical angle, and that light ray bends into the same medium, and this process is called total internal reflection. These are the three properties which play a major role in working of optical fiber. Okay, look at here, total internal reflection. The light ray is completely reflected back into the same. Why it is reflected back into the same medium? Because the angle of incidence for which angle of refraction becomes more than greater than 90 degrees. If the greater than 90 degrees, then only it will reflected back into the same medium. In this figure, look at here, if it makes exactly 90 degrees, it is travel along the boundary. Refracted ray travels along the boundary. If it makes less than 90 degrees, it is just bending. It shows bending property only, and that bending property is called refraction of light. Once again, learn these three properties definitions. The phenomenon of bending of light at the boundary between two different media is called refraction of light. Here I is angle of incidence, R is angle of refraction. Look at here, for critical angle, the angle of incidence for which angle of refraction becomes 90 degrees, then what happened? The light ray travels along the boundary. Total internal reflection means the angle of incidence for which angle of refraction is greater than critical angle, that means greater than 90 degrees. Then what happened to that light? That light is reflected into the same medium. That property is called total internal reflection. Right. Next, laws of refraction. Laws of refraction means refraction has to follow few laws. In that, the first law is the incident ray, the refracted ray, and the normal at the point of incidence all lie in the same plane. Look at here, angle of incidence, the incident ray and the refracted ray and the normal at the point of incidence all lie, that means all lie in the same plane. This is the law of refraction. That means they have a common point, okay, where they lie in a same plane. And the next one is law of refraction. Law of refraction means here, for two give the ratio of sine of the angle of incidence and the sine of angle of refraction is constant. The ratio of the sine of the angle of incidence and the sine of the angle of refraction value is becomes constant, and that constant is indicated with mu. Look at here, this sine I by sine r is equal to mu, where mu is called refractive index. Please note this point, mu is called refractive index, and this law is called Snell's law, and it is a second law. What is the second law of refraction of light? Sine of the angle of sine of incident angle and the sine of the angle of the refraction is constant. This is called Snell's law. Next one, the incident and refracted rays are on opposite side of the normal at the point of incidence. You already seen this point in first PPT where the incident ray and refracted ray both are on opposite sides. Once again I am showing this property. Look at here. Here incident ray and the refracted ray both are on opposite sides. Look at here, it is in rarer medium, refracted ray is in denser medium, and the incident ray and refracted ray both are on opposite sides. What is the first point of refraction or loss of refraction of light? Incident ray, normal point of incidence, refracted ray are lying at a common plane, lying at a common plane, and the angle of sine of angle of incidence and the sine of angle of refraction is equal to refractive index. That means it's a constant and it is denoted with mu. These are called laws of refraction. Look at here. Here incident ray and refracted ray are on opposite side. Refractive index is equal to sine I by sine r. This is the second law, and the third law is incident ray and refracted ray are on opposite sides of normal at the point of incidence. So these are the laws of refraction of light. What we learned up to this, we discussed refraction of light, and the second one is critical angle and total internal reflection, loss of refraction of light. And now there are few conditions the total internal reflection has to follow. Please look at here, what are the conditions? The light should travel from a medium of denser medium to lower medium. So denser medium to lower medium means it is denser medium to rarer medium. The light should travel from a medium of denser medium to lower medium. Next, the angle of incidence of light ray should be greater than critical angle. Yes, if the angle is not greater than critical angle, then there is no total internal reflection. That's why the angle of incidence for which angle of refraction compulsorily greater than 90 degrees, then only this total internal reflection process takes place. Otherwise, if it is not greater than 90 degrees, then there is no total internal reflection. To happen total internal reflection, the angle of incidence for which angle of refraction is compulsorily greater than 90 degrees. If it is exactly 90 degrees, then that refracted ray travels along the boundary. If it is less than 90 degrees, it bends into the another medium. That's it. If it is less than 90 degrees, the light ray bends. If it is exactly 90 degrees, then the light ray travels along the boundary. If the angle of incidence for which angle of refraction is greater than 90 degree, in this case only the light ray completely reflected back into the same medium. Okay, this process, this property is called total internal reflection. To total conditions of total internal reflection means the angle of refraction should be greater than 90 degrees, and the light should travel from denser medium to lower medium. Otherwise there is no total internal reflection, right? And the next the main topic is optical fiber. What is optical fiber? optical fiber is a technology, it's a device. This device can be used to transmit the data to longer distances with fewer damages, with fewer damage or with very less damage. We can send the data from one place to another place. This device plays very important role in communication. Okay, nowadays most of the communication devices are made with the help of optical fiber, not only in communication field, in medical field, in military uses, in decoration purposes, we are using optical fiber. This optical fiber has a wide range of applications, not only communication, mostly it is used in communication, but beyond the communication it has very large applications in medical field also. We have a large applications of optical fiber. This optical fiber works on the principle of total internal reflection. You just know, understand the what is total internal reflection. Depending upon the total internal reflection property, this optical fiber is working. So what is optical fiber? And look at here, I am giving definition here. An optical fiber is a dielectric waveguide. Dielectric means it does not allow the current to passes it, which does not allow the electricity to passes through it. That material is called dielectric. So plastic is a dielectric, glass is a dielectric. That means dielectric materials are used to construct this optical fiber. That's why we are saying in the starting point of the definition, optical fiber is a dielectric. Dielectric means which does not allow the electricity to pass through it. Okay, so an optical fiber is a dielectric wave guide. It guides the wave, it shows the direction. Okay, it shows, it guides the wave. Which wave here we are taking? Electromagnetic wave. Okay, which carries the data. So an optical fiber is a dielectric wave guide through which electromagnetic energy in the form of light can be transmitted. Transmitted means moving from one place to another place with very little leakage. Waveguide is a cylindrical or rectangular shape made of glass or plastic. Why we are taking glass or plastic? Because we need a dielectric medium. Okay, that's why we are taking glass or plastic to construct this optical fiber. This optical fiber is completely made up of with glass and glass or plastic. And this main principle of the optical fiber is total internal reflection. It works on the principle of total internal reflection. What is total internal reflection? Means the angle of incidence for which angle of refraction becomes greater than critical angle, then that is called total internal reflection. In tomorrow's class we discussed how total internal reflection is used in optical fiber, and what are the major parts of optical fiber. And light gathering capacity of a optical fiber. We can discuss more about optical fiber working in tomorrow's class. So once again I recapitulate what we discussed today. We discussed refraction of light, examples of refraction of light, critical angle, and total internal reflection, and laws of refraction of light, and what is optical fiber. So in tomorrow's class we discuss what are the parts of optical fiber, like what is core, what is cladding, what is acceptance angle, what is numerical aperture, what are the applications of optical fiber, how total internal reflection is utilized in optical fibers, how it transmit light from one place to another place. These topics are discussed in tomorrow's class. So how these questions are asked in your examination? In your examination he is asking, define refraction of light, define critical angle, define total internal reflection, and these are the 2 marks short questions. Define critical angle, define total internal reflection, and define refraction of light. These questions comes under 1 or 2 marks questions in your end exam. And write the property of I'll write the laws of refraction of light. Okay, these questions comes under 3 marks questions. And what is optical fiber is also asked in your examination, like define optical fiber. Okay, so this is the today's topic we discussed. I hope you are all understand what is refraction of light, what is critical angle, what is total internal reflection. So there is a little bit confusion, but if you understand clearly you can eliminate your doubts. What is that? Refraction property means the bending property of a light is called, I am concluding what we discussed today. So the bending property of light is called refraction of light. When it is bends, when the light ray travels from one medium to another medium, it bends. During the bending process from denser medium to rarer medium, if it makes an angle of 90 degrees, that means the angle of incidence for which angle of refraction becomes 90 degrees, then that angle is called a critical angle. And what happens if the refraction angle becomes 90 degrees? If the refraction angle becomes 90 degrees, then the light ray does not bends into the another medium. Instead of bending into the another medium, it travels along the boundary line. You have to remember this. If it makes refraction angle 90 degrees, then that light ray travels along the boundary. Okay, this is happen. Okay, if the refracted ray is greater than 90 degrees, refracted angle is greater than 90 degrees, in that case the light ray completely reflected back into the same medium. For example, a light ray travels from denser medium and it strikes on a boundary. at the boundary the angle of refraction is greater than critical angle, then that light ray is not entered into the another medium. That means that light ray does not enter into the rarer medium. Instead of entering into the rarer medium, it is completely reflected back into the same medium. By using this total internal reflection principle, this optical fiber is constructed. This optical fiber is purely depending upon the total internal reflection. If you understand total internal reflection well, then only you can understand the working of optical fiber, which is we are going to discuss in tomorrow's class. Okay, I will show the ppts once again. Please observe what we discussed today with the help of these slides. Look at here. This is the refraction of light. You have to learn this terminology: incident ray, normal, angle of I is angle of incidence, R is refraction angle, a refracted ray. This is air, that means it is a rarer medium, and water is a denser medium. Look at here, it is also another example of refraction of light. For better understanding purpose we are using these slides. And next one is critical angle. Here the light ray is completely travels along the boundary. If it makes refraction angle makes an angle of 90 degrees. Look at here, instead of bending into the another medium, it travels along the boundary. Please observe this blue colored light ray, which is refracted ray along the boundary, and this 90 degrees is called critical angle. It is denoted with c, or sometimes it can be written as theta c. That means critical angle. And total internal reflection, this figure shows three properties in a single slide. You can better understand here by seeing this ppt. Refraction, bended in some another medium. Here bended light refracted ray bended along the boundary. Here the refracted ray reflected back into the same medium. Is more useful slide for better understanding of three properties of light. Look at here, these are the laws of refraction. The incident ray, the refracted ray, and normal drawn at a point of incidence lie in the same plane, and the ratio of the sine of the angle of incidence and sine of the angle of refraction is constant. Sin I by sin r is equal to mu, where mu is called a refractive index. The incident and refracted rays are opposite sides of the normal at the point of incidence. In the conditions of total internal reflection, the light should travel from a medium of denser medium to lower medium. The angle of incidence of light ray should be greater than critical angle. Conditions of, and this is the optical fiber. Look at here, this is the optical fiber, right? So, and what optical fiber is a thin hair thin cylindrical fiber of glass and any transparent dielectric medium. The basic definition of the optical fiber is it is a dielectric waveguide through which electromagnetic energy in the form of light can transmitted with a very little leakage. This is the optical fiber. It is a dielectric waveguide. So we will discuss more about optical fiber in tomorrow's class. Thank you very much for attending today's video e-lesson. Thank you very much. Bye.